In this video, we are going to do an example to understand the property 6 much better. Show that a minus b minus c, 2a, 2a, 2b, b minus c minus a, 2b, 2c, 2c, c minus a minus b to be proved equal to a plus b plus c the whole cube. Now, as you look at it, the elements in the left hand side looks very complicated, and the right hand side is a very convenient value, a plus b plus c the whole cube. So how are we going to arrive at it? We're going to use the property 6 in a much better way to arrive at the solution. So let us proceed. Consider the left hand side. The left hand side is equal to a minus b minus c, 2a, 2a, 2b, b minus c minus a, 2b, 2c, 2c, c minus a minus b. Now I am going to apply r1 goes to r1 plus r2 plus r3. So I get a plus b plus c as the element for each of the entries in the first row. So 2b, b minus c minus a, 2b, and 2c, 2c, c minus a minus b are retained as it is. Now take out a plus b plus c outside. So I get 1 as the entry in the first row. The second and the third rows are carried over as it is. Now what do you observe here? You observe that the elements in the first row being 1, 1, 1, we can apply the property along the columns so that any two of them will become 0. So I am going to apply that. C2 goes to C2 minus C1 and C3 goes to C3 minus C1. So what does this do to this determinant? A plus b plus c is taken out, 1 and 0, 0. Now this has to be applied for the rest of the elements in that column also. So I get minus of a plus b plus c is 0, and in the third column it is 0 because 1 minus 1 becomes 0, and 2b minus 2b is also 0, and the last element is c minus a minus b with a minus 2c. So I get minus of a plus b plus c. So as you observe the second and the third column, you can take out a plus b plus c again outside. So from the second column I get a plus b plus c, which when multiplied with a plus b plus c outside to give a whole square. And from the third column also you get a plus b plus c. So as it is having taken out, I get a square there. Now with this I get a cube outside. So it is a plus b plus c the whole cube times 1, 0, 0, 2b, minus 1, 0, 2c, 0, minus 1. Now as you look at it, it is 1, 0, 0 in the first row and 2c is 0 minus 1 in the third row, and the second row is also very convenient. It is 2b minus 1, 0. So any one column or any one row you can expand it. So I am going to expand along the first row. So I get a plus b plus c the whole cube times 1 minus 0, which is equal to a plus b plus c the whole cube only. Now because the rest of the elements are reducing it to 0. So that is equal to a plus b plus c the whole cube, giving out the right hand side very conveniently. So establishing the result.